High above the Earth, an invisible wound cuts through our planet's magnetic shield. A place where radiation surges, satellites glitch, and astronauts witness strange flashes no human should ever see. This glowing distortion threatens the machines we depend on and hints at a deeper instability beneath our feet. Tonight, we enter the South Atlantic Anomaly. There is a place above our planet where Earth's magnetic shield, our only natural barrier against cosmic radiation, buckles inward like a dented piece of armor. Satellites fear it, astronauts dread it, and scientists still don't fully understand why it's growing stronger and more unpredictable with every passing decade. This is the South Atlantic Anomaly, Earth's most dangerous cosmic weak spot. Stretching across the South Atlantic, the anomaly is the region where the inner Van Allen radiation belt dips startlingly close to Earth, just 200 kilometers above the surface, the closest anywhere on the planet. Here, the magnetic field weakens to less than 32,000 nanotesla, allowing trapped radiation to spill downward in concentrated waves. Normally, Earth's magnetic field sweeps these charged particles away. But in this region, the shield sags, inviting chaos from above. This distortion isn't random. Earth's magnetic dipole, the invisible bar magnet at the core, doesn't sit neatly at the planet's center. Instead, it is offset by nearly 500 kilometers, tilted and displaced so dramatically that the Van Allen belts droop towards South America and the Atlantic Ocean. As a result, spacecraft traveling through this zone experience radiation levels far higher than anywhere else in low Earth orbit. But the anomaly isn't static. Since its discovery in 1958, the SAA has been slowly expanding, stretching outward to the northwest, north, and east. Its most intense region drifts westward at roughly 0.3 degrees per year, matching the mysterious rotational differences between Earth's core and surface. Scientists believe this drift may be a clue, evidence that deep within Earth, something colossal is reshaping the magnetic field. Every time a satellite enters this zone, it's exposed to minutes of heightened radiation, enough to scramble data, corrupt electronics, and sometimes wipe out systems entirely. And as the anomaly grows, so does the threat. The South Atlantic Anomaly isn't just a weak spot, it's a warning. Inside the South Atlantic Anomaly, the rules of space seem to bend. Sensors glitch, detectors scream with false alarms, and astronauts report seeing flashes of light with their eyes closed. Phantom streaks dancing across their vision, as if the vacuum itself were alive. In this strange corridor of space, the invisible becomes impossible to ignore. The anomaly is a hotspot of energetic particles, protons trapped within the inner Van Allen belt that plunge closer to Earth here than anywhere else. As satellites pass through, they're bombarded with ionizing radiation strong enough to corrupt memory, disrupt navigation systems, and fry sensitive electronics in seconds. During Space Shuttle mission STS-94, astronauts measured dose rates spiking as high as 175 micrograys per day, far above the norm for low-orbit Earth. Every spacecraft that enters this region prepares for impact. The International Space Station carries extra shielding along sections of its hull specifically to withstand the anomaly's particle storms. Even so, astronauts still report cosmic ray visual phenomena, bright, shooting stars that flash within their retinas as charged particles pass directly through their optic nerves. It's a reminder that in the SAA, the human body itself becomes a detector. Some machines don't survive the passage. Modern electronics are notoriously vulnerable to high-energy particles, and the anomaly has crashed everything from guidance computers to onboard laptops. The Hubble Space Telescope goes completely blind here, shutting down its ultraviolet detectors to avoid irreversible damage. Skylab's solar sensors once triggered false solar flare alarms every time it crossed this region, confusing the system so thoroughly it had to be reprogrammed. The deeper scientists look into the anomaly, the stranger it becomes. It's not just a zone of radiation, it's a volatile domain where Earth's magnetic protection thins to its breaking point, allowing the cosmos to reach in and touch everything that crosses its path. Satellites don't just fear the South Atlantic Anomaly, they die in it. To engineers, this region is known as a failure zone, a place where million-dollar machines enter perfectly functional and sometimes leave in pieces. It's an invisible minefield orbiting above Earth, waiting for the next victim. One of the most dramatic casualties was Japan's Hitomi X-ray Observatory, the most advanced telescope of its kind. As Hitomi drifted into the anomaly, a brief radiation spike disabled one of its star tracking sensors. In an instant, the spacecraft lost its ability to orient itself and switched to backup gyroscopes, faulty ones. What happened next played out like a slow-motion tragedy. Misread data commanded the satellite to spin faster and faster until its solar panels tore away. Hitomi spiraled helplessly into the void, destroyed by a chain reaction that started inside the SAA. The anomaly has claimed others too. The Globalstar communication satellites suffered mysterious failures in 2007. Many traced back to repeated exposure to the anomaly's intense particle flux. The SpaceX CRS-1 Dragon experienced a sudden, unexplained glitch during its passage in 2012. NASA's own laptop computers have abruptly crashed during shuttle flights through the region, proof that even well-shielded systems can be overwhelmed. But perhaps the strangest discovery came from the Pamela experiment, which detected levels of antiprotons, actual antimatter, far higher than predicted. It appears that the anomaly doesn't just flood spacecraft with radiation. It traps antiparticles created when cosmic rays collide with Earth's atmosphere. This turns the SAA into a natural antimatter reservoir, a bizarre consequence of warped magnetic fields. To mission planners, the South Atlantic Anomaly is a place to avoid, reroute around, or sprint through as quickly as possible. To spacecraft, it's a graveyard suspended in orbit, proof that not all dangers in space come from the stars. For decades, scientists assumed the South Atlantic Anomaly was just a slow, harmless wobble in Earth's magnetic field. An oddity, yes, but not a threat. But recent data shattered that confidence. The anomaly isn't stable. It's expanding and accelerating. In the last 50 years, the weakened zone has more than doubled, spreading westward across South America and creeping ever closer to Africa. Satellites passing over it now lose communication more frequently. Radiation spikes are sharper, more violent. NASA once believed the anomaly would smooth out over centuries. Now, some researchers warn it may split into multiple weaker field pockets, creating not one danger zone, but several. Behind these changes lies a disturbing trend. Earth's magnetic field isn't just weakening at the anomaly, it's losing strength globally. And the fastest drop is happening right at the South Atlantic. The field has been fading at an abnormal rate, far beyond the quiet fluctuations scientists expect over millennia. If this decline continues, the planet could reach a tipping point where the poles begin to wander unpredictably, or even reverse completely. It has happened before. The geological record shows sudden collapses, chaotic magnetic flips, and long stretches where Earth's protective shield nearly vanished. And each time, something triggered the shift. Something deep, unseen, violent. The South Atlantic Anomaly may not simply be a curiosity. It may be the first warning sign that Earth's magnetic engine, the molten core itself, is destabilizing. A silent change, accelerating in the dark, and no one knows how far it will go. The South Atlantic Anomaly is more than just a hazard for satellites. It may be a message from the planet itself. Deep within the Earth, beneath the shifting continents and oceans, something colossal is reshaping the magnetic field. Scientists point to the African Large Low Shear Velocity Province, a dense, mysterious structure in the lower mantle, as a possible source. Its immense mass disrupts the flow of molten iron above it, warping Earth's magnetic field and pulling the Van Allen belt unnervingly close. As the anomaly expands, the implications ripple far beyond orbit. Satellites face growing risk, astronauts encounter strange visual phenomena, and sensitive experiments are repeatedly sabotaged by invisible radiation. But the anomaly could also be a harbinger of geomagnetic instability, a weakening that may presage a magnetic pole reversal, a phenomenon that has occurred many times in Earth's history. When the poles flip, compasses point south, the magnetosphere falters, and the planet becomes vulnerable to solar storms and cosmic radiation. Some researchers speculate the anomaly may even interact with space weather events, amplifying solar flares and geomagnetic storms in ways we barely understand. Historical projects like Operation Argus, attempts to manipulate the radiation belts, hint at humanity's fascination with controlling forces far greater than itself. But the planet's own mechanisms are far older, stronger, and far less forgiving. For now, the South Atlantic Anomaly drifts slowly westward, a subtle growing scar across the magnetic shield. It is Earth's invisible warning, an unstable, shifting force that reminds us that our planet is alive, dynamic, and unpredictable. And as satellites continue to fail, and astronauts witness phenomena that defy explanation, one truth becomes clear. The anomaly is not just a threat. It is a riddle written into the very heart of our planet, daring us to decipher it before it changes the rules of life above and below. The South Atlantic Anomaly is more than a patch of weak magnetism. It is a living, shifting scar in our planet's defenses. A reminder that Earth is far stranger and more powerful than we imagine. Satellites falter, astronauts see impossible flashes, and radiation silently seeps closer to the surface. Every crossing reveals new dangers, new mysteries, and new questions about what lies beneath our feet. Could this anomaly be a warning of a magnetic reversal? A signal of deep, hidden forces within the Earth? Or a natural phenomenon we are only beginning to understand? The truth is elusive, but the anomaly continues to grow, drift, and haunt the skies above the South Atlantic, daring humanity to pay attention. If you crave the unexplained and want to explore the mysteries that challenge our understanding, subscribe and turn on notifications. And as always, don't forget to look beyond the fog.